Hello everyone, welcome to this session. In this session, we will talk about the support vector machine, so what it is, and its fundamental concepts that you need to first understand before go deeper into it. So first, let's recall the classification problem, because later we will explain SVM using the classification problem. So let's see, now we are classifying a fruit. So we want to see if a fruit is an apple or orange. So we can see the training data, we can see it's here. The 2 apples and 2 oranges and many more. So each of them, we have a label, right? Then the test data is this one. So we want to recognize is an apple or orange. Then we will select a machine learning model. So we can see the features. We extract the shape and color are 2 features. So then we will have a category 1 and category 2. We use apple and orange, so we can describe their shape and color. Right. So now what we want to do is to learn a tree classifier to see that if the classifier can separate the training data the best, right? So probably with the separation is like this. Then I will provide the test data, and you can see it comes to one of the category. So in this case, the new data is categorized as an apple, right? So this is a classification, and SVM we will the most widely used application for SVM is classification. So in real world, there are many applications of SVM for classification. So in this table, I list a few of them. So if, for example, your mobile app, the recommendation system, so we input the ratings, the clicks, or the likes, so it provides a preference score, right? So that we can learn this. Also for the fraud detection, your mobile banking or your email, you can the machine can suggest if one request is a fraud or not. And also in medical, we can identify the tumor diagnosis. So we can see the medical images, identify the tumor or not. And for the handwriting recognition, you have already seen it before in previous sessions, right? So SVM is widely used in these areas. So we can see, although SVM can also be used for regression, but the most widely used application is a classification. So if I was asked to suggest you to only learn one classification algorithm, then I would suggest a support vector machine, right? Because it's a very influential algorithm and used everywhere, as I've just shown. So this method have a very solid mathematical background, and this SVM we carry out a hyperplane-based classification. So let's see, there is a class positive 1, and here is a class minus 1. Then we have a line here to separate the 2 classes, right? And we can see we also have 2 dashed lines. You can see this one just has a point here, right? So these 3 lines are very important in SVM. So we call the green line, we call it the hyperplane. So SVM separate data by this hyperplane. And for this point and this point, we can see these are the nearest point to the hyperplane, right? So we can see the distance between the dashed line and the green line. We call them the separation margin. Another concept, the dashed line themselves, we call them margin boundaries. So here now we learned 3 basic concepts: hyperplane to separate the data, and when we find this point at this point, and the hyperplane is in the middle of them, but this distance and this distance are the same, right? So each of them, we call them the separation margin. And the line here and here, we call them the margin boundaries. Remember these 3 concepts. So let's see them one by one. We first see the hyperplane. So hyperplane we can see is a decision boundary. this one separate the data into different classes. So we can consider is like some points that satisfy the following equations. We can see the hyperplane hx equals to w transpose multiply x plus b equals to 0. So these w and x, both of them are vectors. So we can see is w1 x1 multiply x1 plus w2 multiply x2 till wd multiply xd, right? So and plus b equals to 0. So this w, we call them the normal vector of the hyperplane. So b is a scalar. So as we can see if in 2 dimensions, class positive 1, class negative 1, there is a hyperplane here. So this one we consider is like a w transpose multiply x plus b equals to 0. This is a line. So they understand this, we need the analytical geometry knowledge. And so this direction, we call it the normal vector. On this side, we have this equation's value is larger than 0, and on this side, it's smaller than 0. Right? So we can summarize it like, for the hyperplane, for any point x, if this one equals to 0, it lies on the hyperplane. So if this equation is larger than 0 or smaller than 0, it falls in the one side of the hyperplane, right? So this is a hyperplane. So to separate the data, right, to different classes, we need a separating hyperplane. So what is separating hyperplane? We can say that is a hyperplane used to separate data. So we call this, straightforwardly, we call this separating hyperplane. One hyperplane, we separate the space to 2 half spaces, which belongs to 2 categories, right? So if it's 2D, a hyperplane is a line. If it's 3D, a hyperplane is a plane, right? So for higher dimension, we can't imagine it, but we can, let's see some examples of 2 and 3 dimensions. So we can see there are two kinds of data. So if we use a hyperplane, if we use a curve like this is not hyperplane, because this is not a line, it's a curve, right? So this one, if we separate it by a line, we say this is a hyperplane in 2D data, right? So if it's 3D, we can see how it goes. It's like this, right? So in 3D, this is a separating hyperplane. So this is the concept of separating hyperplane. And SVM in training, we want to find the best separating hyperplane. So what is it? Before introducing this concept, we first need to understand another concept which we call linearly separable. So linearly separable data, it means the data set, we can find a hyperplane to separate them. So some data we can't. In the later sessions, we will see them, right? So for linearly separable data, often there exist many or infinitely many hyperplanes to divide it. Then we need to find the best one. But this best one is a training result, right? So then we can see some example. So this is a positive one data, negative one data. So here we use one hyperplane, and we can see what is this. This is what? Margin, right? Remember the previous figure we showed just before. This we call the small margin, boundary margin. So if we see in using this hyperplane, the margin is here. If we use this hyperplane, we can see the margin is here, right? So this margin is larger than this. A question, right? So do we want the margin to be larger is better or the smaller is better? Right? So we want a larger margin, right? So why? Because the larger margin, we can have a more generalization to the test data, right? So we can see that this is the best hyperplane, and because it has the largest margin, so that is the principle that the SVM used. So SVM training, we hope to find the hyperplane with the maximum separation margin on the training data. So in this way, it has better generalization ability. So what is generalization? we have introduced in the last session, right? So for new data, it also works well, right? This is generalization. The last concept introduced in this session is support vectors, right? So what are support vectors? So the support vectors are those vectors that have the minimum distance to the hyperplane. So we call them the support vectors. So let's see a figure. So where are the support vectors if we see the hyperplane is here? So we can find, first draw the boundary, and we can see those with the minimum distance are here, here, and here, right? So these are the smallest distance to the hyperplane. So we can see this one, we call them the support vectors. So support vectors means support of SVM. So this means the other data. So for example, those here and here. So those ones are not affect the SVM decision. So even if we just remove them, it's also okay, right? So that's why we call this kind of classification, this algorithm, we call it support vector machines, SVMs, right? So these are the basic concepts for SVM, and then we will see how it works in the next session. And before that, we will introduce different kinds of SVM. So thank you for listening. Bye-bye.